The first function implemented in the project is the timer2interrupt function. Timer2 is set using a PSC value of 1599 and an ARR value of 9, producing a clock interrupt of 1000 Hz or refreshing every 1 millisecond. As such, this interrupt function is used to keep track of all the counters used within the project as they update every 1 millisecond. Another use of this function is to control the flashing of each LED depending on the state of the system. To do this, there are 4 if statements for different cases. The first if statement is when the system is in state A and therefore all the lights should be switched off. This is completed using the HOW GPIO write pin function, which turns all 3 LEDs to a reset state. The second if statement activates when the system is in state B and when the previous toggle of LED 3 has been or exceeded the LED 3 delay variable. This variable is determined by the ADC to change the frequency of the LED's flash. If this condition passes, then the HOW GPIO toggle pin function changes the LED pin between set and reset, causing it to flash. The final 2 functions are extremely similar and are actually alternatives of each other. This means that they have the same structure, however differ by the state of the onboard push button. If pressed, the green LED will toggle at 2 Hz, while if released, the blue LED will flash at 2 Hz. The map function takes 5 integer inputs and returns a single integer. The purpose of this function is to interpolate one value in a range to a range of another. It is extremely useful in determining the LED3 delay variable to control the flashing frequency of the red LED, and the duty cycle variable to control the position of the servo. The update state B function is used to update the LCD screen to display the information required for state B. When the function is called, it checks whether the last iteration was at least 300 milliseconds ago, and if this condition is met, the counter is reset and the ITOA function is used to convert the ADC value integer to a char list. This is important as the print string function used to display data to the LCD cannot display an integer. From here, a combination of setCursor and print string functions are used to display the information on the LCD. The update state A function is the same as the previous function, however, the data that is displayed is different. In this function, there is no need for the ADC value, thus the ITOA function is not used. The only other difference is that the data provided to the LCD is different. Finally, the main loop holds the main function of the assessment. On startup, the system starts in state A and thus calls the update state A function to start. Next, the ADC conversion is stated using the HOW function on line 250, and this value is assigned to the ADC variable using the HOW GPIO getValue function. As mentioned previously, the integer value is then converted to a char array that can be used to transmit to the serial using user transmission. If the transmission counter is greater than or equal to 500, it transmits once again, providing a refresh rate of 2 Hz. The if statement on line 265 detects if the push button on the breadboard is pressed at any point. This causes the system to change to state B. A while loop is then used to ensure the system remains in this state until the button is pressed again. While in this state, the code repeated involves taking the ADC value and interpolating it to determine the correct duty cycle for the servo and delay for the LED. The other operation in this state involves calling the update state B function to update the information displayed on the LCD.